Hi everyone, welcome back. So as you can see, right now I am still at the piano right here, but now I have open Logger Pro, the program that actually can capture, in this case, it's going to capture a very specific frequency. So what you're seeing is just some white noise. If I just press the space bar right now, it's going to be a lot of, nothing, as you can see. So let me explain what this graph is so you can kind of understand it. So this y-axis is the amplitude. It's the loud, measuring the loudness of the sound that I'm going to make. And the bottom is the frequency right here. So we're going to be measuring the piano frequencies in this lab. Now, one thing that's really important is that we're doing this thing called the fast Fourier transform. It's actually a pretty advanced mathematical method to picking out all the frequencies in a wave function. So we'll skip the math of that. If you're curious, I'd be happy to show you. But we're not going to do that. What we're going to do is we're going to use the fast Fourier transform to select out the frequency that this piano is playing. So let me just give you a quick example of that. I'm going to press collect first and then the note. And there it is. Beautiful. Textbook example. So first of all, I hope you notice that a piano doesn't play one frequency. It plays many distinct frequencies. Notice that there's multiple peaks here, but one of them seems to be pretty loud. Notice that right there. But look that we have another frequency here, 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 etc. You can see they're very distinct frequency. This is a characteristic of the harmonics of this piano. And in fact, what we're seeing too is a mathematical relationship between all of these, which is pretty cool. So right now, we're going to be isolating and looking at the peak frequency. So notice the peak frequency is 261.23 hertz. And if you notice my mouse, I can mouse it over here. It's also this case right here, but I'm using this mouse examine tool to actually find it. So there it is right there. I'm going to go back to the 261 because that seems to be the note right there. So on your lab, you should notice that you have this thing called C4, which is our middle C right here. This is the note that I'm playing, and that's the frequency. You'll notice the column that says frequency. This is what you're going to put in that frequency column, is the 261.23 hertz. And then basically, you're going to record. I'll identify it on the program here, and you're going to record it. So you would do this part in lab normally, but obviously I'm going to do it for you just so you can get that experience. So you can actually go ahead and write down that frequency 261.23 hertz for middle C. The next note I'm going to play is the note up right here. I can't remember if it's C sharp or D flat, but either way, it's the next row of your program. So I'm going to go ahead and press collect first. And interesting that actually the note that we want is here. I'm going to try that again. Interesting. Oh, that's okay. Sometimes this happens. So your next frequency is the following. I'm going to let you read it this time. I'm going to play the D now. Going to play E flat. Also known as D sharp. Going to play E. Ooh, that's a bad one. Now I'm going to play F. F sharp. G. G sharp. Also known as A flat. A. E flat. Oh, that's a bad one. There we go. B. C. This would be C5. Oh, that's a bad one. Still a bad one. It's better. Okay, I'm now going to play E5. I'm going to play G5. Now I'm going to play C6. Okay, those are all the notes in the lab. If you missed something, I think it's obvious, but I'll say it anyway. You can stop the video at any time to pause as you write down the frequencies for each of those notes. And then the next step is to do all the calculations as explained in the lab. Have a good day.